So now to end our tutorial, I wanted to talk a little bit about graphing and just graphing functions. So here, notice because when we were in our mode, we left it on function mode up here, func. So we want to graph a function, and that is with this, the y equals key. So to bring that up, it brings up where I can now input my function. So our first graph will do something similar, or simple, excuse me, like y equals 3x plus 1. So I'll go 3, and then the x, something we haven't talked about yet. Where do we find this variable x? We have a very convenient key right here I'm pointing to, this one, that has an x, a t, a theta, and a little n. And whenever we're graphing, whatever mode we're in, this will always be the right variable for that mode. So if you go parametric, it'll automatically choose the t for you, etc. And so right now we're in function mode, it'll automatically choose the x. So I'll just push that for x. So y equals 3x. I'll go plus 1, press enter to save it in, and now I want to graph it. So I'll look for the button that is labeled graph. In this case, it is right up here. When I hit graph, it just graphs this nice graph for me. And like I mentioned, I think before, we can actually graph more than one thing at once. So let's say we wanted to do x squared, minus 2x minus 1. So I will go x, notice I'm using that key again. Squared, there's either a squared button, which actually I failed to point out before. If you ever need to just square, just push that. Check it out, automatically squared it for me. Or, if I wanted to, I could also push the caret button, which will take me up, and then just choose the power of 2. Now remember, look, I'm up here, so if I did x squared plus 2x, plus 2x, now look, that's in the wrong spot. That's not going to work out right. So when I'm done with the exponent, I need to make sure to push the arrow key to kick me back down. So we'll go plus 2x, minus 1. Press enter to select. Now when I graph this, we will end up with a nice parabola that will go along with our line. There we go. Now what's cool with this is there are times that we will solve equations. So get two equations. Let's say that the two equations you were given were these, 3x plus 1 and y equals x squared plus 2x minus 1. And they might ask, what is the intersection of these two? And that's something that we can actually figure out very quickly using this tool, and I'll show you. Notice above my finger it says the word calc. That's how we calculate things in our graph. So I'll push second to access the calc menu. Now I want to find the intersection. Where do these cross? So first I'll have to identify which curve am I dealing with, because there's a chance you could have more than two curves, so it doesn't just know these are the two we're dealing with. In this case we only have two, but I still need to select them. So the first curve will be the first equation we typed in, 3x plus 1. I'll push enter. Second curve is our second equation, as seen up here, x squared plus 2x minus 1. And then my guess. Notice I actually have two intersections, so I need to guess. We're going to do whatever intersection is near here. And now our intersection is actually 2, 7. How convenient was that? This saves a lot of work to be able to find the intersection. This is a good tool for on your test. Obviously, you'd have to show your work or else your teacher would take away points, but this will help you to know whether you found the right answer or not. So using the same tool, calc, let's go back and find the other intersection. So my first line, the 3x plus 1, I'll choose it, and then the x squared, I'll choose that one too, but now my guess is going to be down here. And notice it just follows right along the curve. And if I push the down key, oh, that must be another version, excuse me. So as we skip along, let's get, okay, that's pretty close to where I want to be. Let's push enter, see what we get. And the second intersection is -1, 2. So that is a good tool for helping you figure out intersections. Another useful tool, in fact, I'm going to go here to this, and I'm just going to clear out this row. So we're only looking at the parabola now. Now sometimes you want to know where is the minimum of your function. So in order to find the minimum, same place, calc, you may have even seen it before, minimum. And then you just go left bound, go a little bit left of the bottom, and a little bit right of the bottom. And then my guess, I'm probably going to have to redo all that again. Yep. Don't hit the wrong key or else bad things happen. So left bound, right bound, and guess. It's somewhere near here. And then it figures out for me, hey, the minimum is right there at -1, 2. So very useful tool in helping you to find values. It'll also help you find zeros, which in this case is just going to be an approximate 0, it looks like, but let's check it out. So if we go calc and the zeros, and so similar to the last part, we go left bound, so we'll go a little bit left of our 0. Here's a little bit right of the 0. And then I guess right here is pretty close. And there you go, 2.4124, etc. Now notice that's only a decimal approximation, but if you do the math for it, you could type in the calculator and see if you got back the same answer, because this will help you to verify that you have found the correct 0. So graphing not only helps you get a feel for what it looks like, but you can also use it to help find things like 0, like intersection, and things of that nature. Now sometimes when you graph something, you might not be able to see all of what you want. Like for instance, right now I am in degree mode. So if I graph like a sine of x, it's a lot of degrees in a circle, 360 degrees. And so this is not going to look like, if anyone's familiar with what a sine wave looks like, it's not necessarily going to look right, because it is only going to show us part of it. And so it's going to look really confusing. So with this, that was basically not useful at all. There's a little tiny bit we can see that showed up here, and a little tiny bit we can see over here. Now when we have a sine or any of these functions, it is important to know what is the amplitude or range of the function going to be. So here I can change that in what's known as the window. So this lets me know what do I want to see. Now with the sine graph, the tallest it's ever, or the lowest it's ever going to be is -1. So I'm going to go -1.5, and the tallest it'll ever be, the y max, is going to be 1, so I'll go +1.5. So now it's going to kind of zoom in and only show me that portion in the y. And then I know that it's going to go, one full cycle would be -360 back versus +360 forward. So now when I graph, it should give us a very nice representation of 2 full cycles of a sine graph. And check that out. So now it actually became useful, but I totally had to mess with it. This, to put in perspective, this height from here to here, that's only 1 unit tall. But from here all the way over to here, that's 360 units. So it is not a nice square shape anymore, but it helps us to see what's going on with the graph. So there are times when it's worth changing the window to be able to see things better. However, if we go back, and now I want to look at my 3x plus 1 again, our first graph, when I go to graph it, it's going to look really weird. In fact, it's going to be just not even going to show up because it's going to be so similar to this straight line. So now I say, well, what am I going to do? I have to go back. I don't remember what that was, my original zoom, my original window. Luckily, there's this zoom key. So no matter where you are, you can always go back to zoom standard, or my preferred is zoom decimal. And it takes us right back to home base, to a nice normal looking zoom. Zoom standard is also a good basic one. It takes you right back so you get an idea for what it is. No matter what you change it to, you can always go back to zoom standard. I will explain. I prefer using zoom decimal because it's hard to see from the picture, but each pixel here, as I move, will represent 1 decimal. So notice that there's 0, 0.1, 0.2, 0.3, 0.4, 0.5. It goes up. So it's really easy. This is, in my opinion, the easiest one to view to see where things are. And this actually will give you a good approximation of a value as well. You want to get up, you want to get something close. That'll help you approximate just by dragging and looking.